Have you ever just stopped and wondered how your phone knows your face or how your email inbox is so good at catching junk mail? Well, it's not magic. It's something called machine learning. And today, we're going to pull back the curtain on the two big ideas that make it all happen. So let's get into how these machines actually learn. Seriously, think about your spam filter for a second. It's a perfect example of a machine that's learned how to do a job. It just sifts through tons and tons of messages and makes a call. Spam or not spam? But how in the world did it get so smart? That's the big question we're tackling today. It really boils down to two main strategies. On one side, you've got supervised learning. Think of this like studying for a test when you already have the answer key. Easy enough, right? But on the other side, you've got unsupervised learning. This is more like being dropped in a huge library with zero instructions and just being told, hey, find some interesting patterns. Totally different approaches for totally different problems. All right, first up, let's explore that answer key method. This is what we call supervised learning, and it is all about teaching by example. So the absolute key here is that the data is labeled. We don't just throw a bunch of emails at the machine. No, we show it thousands of emails, and we tell it for each one, this is spam. And this one, nope, not spam. The algorithm's whole job is to figure out the patterns, to see the connection between the email's content and that correct label we gave it. So one of the most intuitive ways to do this is with an algorithm called k-nearest neighbors. You'll just hear it called KNN. The idea is actually brilliantly simple. You are who your neighbors are, and the K, that's just the number of neighbors we decide to look at. It's basically a popularity contest for data. And what's so cool here is how it all just comes down to a vote. To classify a new email, the algorithm looks at, let's say, the 5 most similar emails it's already seen before. It calculates the distance, to find the closest ones. If, say, 4 of those 5 neighbors were already labeled spam, well, guess what? The new email gets called spam too. The majority rules. But, okay, what if a simple popularity contest isn't quite gonna cut it? Well, that brings us to another awesome technique, the decision tree. If KNN is a popularity contest, a decision tree is much more like a strategic game of 20 questions. The algorithm literally builds a flowchart of yes or no questions. It starts with the entire dataset and asks the one question that will best split it into cleaner groups. A question like, does the email contain a suspicious link? That creates 2 branches. And it just keeps asking new questions down each branch, splitting the data more and more, until it gets to a final answer, what we call a leaf node. The whole goal is to make the groups at the end of each branch as pure as possible. Okay, so that's learning with an answer key. It's pretty straightforward. But what happens when you don't have one? What if you're just staring at a massive, messy pile of data with no idea what the categories even are? Well, that's where our second big idea comes into play. Welcome to the world of unsupervised learning. Here, the data has 0 labels. No spam, no not spam, nothing. It's just raw information. So the machine's job isn't to predict a known answer. It's to discover the hidden structure within the data all by itself. It's pure, unadulterated exploration. And the most common type of unsupervised learning is called clustering. Here's a great way to think about it. Imagine you've got a giant pile of laundry on the floor. You just naturally start sorting it into groups, whites over here, darks here, colors over there, based on what looks similar. Nobody had to tell you those were the categories. That is exactly what clustering algorithms do with data. So how does a popular clustering method like k-means actually work? Let's picture it. First, imagine all of your data points just scattered on a graph. They're just floating around, no labels, no groups, no nothing, just a cloud of data. Okay, next, the algorithm basically makes a wild guess. If we tell it, hey, we think there are probably 3 groups in here, it will randomly drop 3 points onto the graph. We call these points centroids, and they're the starting guess for the center of each group. And now, this is where the magic happens. First, every single data point gets assigned to whichever centroid is closest to it. This makes some messy initial groups. Then, and this is the clever part, the algorithm finds the new middle of each of those groups and moves the centroid there. And then the whole thing repeats. Assign the points to the new centers, then move the centers again. It does this over and over until the groups stop changing and become stable. The data has literally organized itself. So this is all really cool, but where do these powerful ideas actually show up in our day-to-day lives? Let's connect all this back to the real world because it's everywhere. Supervised learning is all around us. anytime there's a task with a clear right or wrong answer. That spam filter we keep talking about? Classic example. But so is the speech recognition on your phone that turns your voice into text, or a fingerprint scanner. In all of these cases, the machine was trained on tons of labeled data, so it could learn to predict a known outcome. Unsupervised learning, though, that's where the real discovery happens. Companies use it to find natural groups of customers for marketing campaigns. Security systems use it to spot weird activity, anomalies that don't match any known pattern of attack. And get this, scientists even use it to group DNA sequences, uncovering biological relationships they never even knew existed. So we've got two different toolkits for two very different kinds of jobs. How do you know which one to pick? Well, it really just comes down to your goal and, of course, what kind of data you have. This table really just lays it all out for us. Look, if your goal is to predict something you already know the answer to, like spam or not spam, and you have the labeled data for it, you want supervised learning. Use something like KNN or decision trees. But if your goal is to just explore and find hidden groups in raw, unlabeled data, you need unsupervised learning with a tool like k-means clustering. And I love this quote because it just sums up that whole discovery process so perfectly. The entire goal is to find things that belong together and separate them from everything else. It's such a simple concept, but it's incredibly powerful when you put it into practice. So from learning with an answer key to discovering patterns all on their own, these two big ideas are really the foundation of so much of modern AI. They're already changing our world in massive ways, and honestly, they're only getting better. Which leaves us with a really fascinating question to think about. What's the next great challenge we should ask them to solve?